Welcome to this series where we look at what makes Onshape unique compared to other 3D parametric design tools. In this video, we're taking a look at frames in sheet metal and how they provide process-specific advantages. Starting with frames, most of the workflows in Onshape will feel very familiar throughout the design process. Add frame members to existing geometry while defining the orientation, alignment, and corners of members. Onshape dynamically trims frame members while they're being created, and you can add additional components throughout the design process, such as end caps and gussets. Where Onshape is unique is its ability to capture manufacturing information early to help make design decisions. In Onshape, you can add your cut list directly to the 3D model without the need for a drawing. Onshape allows you to create discrete cut lists for different areas of the design, useful in scenarios where you're designing a complex weldment created from multiple sub-weldments. You are not limited to a single cut list for a design. In other cases, you may want to create multiple weldments created in the same part studio to take advantage of modeling the common features on multiple frames at once. If you ever change your mind, you can make changes to the cut lists in real time. As you remove cut lists from the model, they're removed from the cut list pane automatically. You can also simplify the entire cut list creation process by simply choosing to add all frame members to a cut list. For items that aren't frame members that you want to include in your cut list, you can choose to add these items and define any of the properties to include in the cut list. Perfect for custom items like end caps, plates, and brackets. Importantly, the cut list dynamically updates as any changes are made. Speaking of brackets, let's take a look at adding some sheet metal components to a frame design, as Onshape allows you to mix and match any component types. Sheet metal components can be created in a variety of ways. You can start a component by extruding existing sketch entities to define the part like other design tools. However, as soon as a sheet metal component is created, its flat pattern can be viewed from the flat pattern pane. This flat pattern is a live representation of the flat pattern for the component, so as changes are made, they can be realized in the flat pattern in real time. Not just as features are added either, but even the previews of new features, ensuring you're designing what you want before you commit a feature change. In other cases, you may want to start with the shape of the sheet metal part using traditional features like extrude to define the design requirements of the sheet metal part. Onshape allows you to convert any solid into a sheet metal component easily. Simply select the faces to exclude from the sheet metal component and define where the bends in the part should be. The real-time flat pattern isn't just useful for understanding the blank version of the part, but you can use this in real time as well to add features to the flattened part, especially useful for features that need to be geometrically accurate across bends. This is perfect for features such as spot weld cutouts on brackets. Again, you can see the preview in real time, but also on the formed part as you're adding the feature to the flat pattern. Another example is converting an already designed machine part into a more economical sheet metal version. In cases where convert may be too complex, you can use Thicken to rapidly select just the faces that are important to the sheet metal version of the component. For the existing part, you can choose to hide it or completely remove it from the design if it is no longer needed. This allows your designs to evolve as opposed to having to create completely new parts. Again, using the real-time flat pattern, you can use this to also better control the blank of a sheet metal part to reduce unnecessary waste and costs like the ends of a flange that extend past the functional needs of the blank. And of course, for manufacturing these sheet metal components, you will want to export the flat pattern to formats like DWG or DXF. This is easily accomplished in Onshape, where it can be exported to an external file or even saved within the same document where the sheet metal components are designed. Finally, the cut list in a design should represent all of the components and instances that define the welded frame. In order to accomplish this, the cut list feature should appear at the end of the feature list. Once this is done, you have an accurate cut list available before any drawings are even created. Once a drawing of the frame is created, the work of creating the cut list has already been done. All that is needed is to add the cut list to the drawing and snap it into place. As you've seen, Onshape offers unique solutions to common challenges when working with both frames and sheet metal components, with a focus on your manufacturing needs so you can focus on the important aspects of designing these unique product types.